For these notes, we are going to look at the different types of chemical reactions, because once we know the types of reactions, we will be better able to predict the types of products that can be made afterwards. So there are 6 types of reactions. Sometimes some people call them 5, but we've added a 6th one in here. It's really another type of double replacement, but it does have its specifics. So, starting at the beginning, we have what's called combination or synthesis. And this is really a buildup of particles. It's the most simple form of chemical reaction. You take a piece of this and a piece of this, and you put them together, and you make something bigger. So you can have, generally we see that we have fewer products or more complex products. So we have a couple of examples here. We have sodium and chlorine, so just 2 simple elements that combine to make NaCl. We also have carbon dioxide and water making C6H12O6, or a sugar, and oxygen. This is photosynthesis. This is what's going on in a plant cell to convert the carbon dioxide into oxygen, and it stores those carbon pieces as sugars, so the C6H12O6. And then that is a very complex molecule. Then we have lithium and bromide, which forms LiBr. Decomposition is the reverse of combination or synthesis, and that is when we break down those very complex molecules and form very simple products. So a lot of these are the reverse of the ones we had above. So as you can see, we have NaCl will break apart into the elements Na and Cl. Likewise, LiBr will break apart into lithium and bromine. Now, the reverse of photosynthesis is really what we do in our bodies when we take the sugars from plants, so that C6H12O6 molecule, the sugar, and we combine it with the oxygen that we've breathed in, we can make carbon dioxide and water. So something really important to note about synthesis and decomposition is that they are reverse of each other. So the next type of reaction we're going to look at is called single replacement, or simply replacement. And this is where one element comes in and takes the place of the other element in a compound to make a new compound. So for example, we have iron and copper 2 chloride. That iron is going to switch and kick off the copper and become iron chloride. We also have Na with water, but to make it a little bit easier to follow, we'll write water as HOH. We will kick off those hydrogens and create NaOH. So this N is just kicking off the H so that it can form its own compound. We can do nickel, behaves the same way when you get it near the acid HCl, and we produce a hydrogen gas, and we have nickel chloride. Probably not the best thing to be breathing in is this reaction. We also have fluorine will take the place of oxygen in water and make O2 and HF. So one thing that's really important to notice here is that the metal is replacing the other positive charge. These happen with ionic compounds, and the positive replaces the positive, or in the case of fluorine and oxygen, the negative replaces the negative. So we won't have, like, the nickel, for example, is a metal. It won't replace chlorine, because then that would mean that we would have H plus and Ni plus 2 trying to form a bond, and that just wouldn't work. So we always have the element that is coming in will replace either the positive or the negative, whatever matches itself. So our next type of reaction is called double replacement, and this is a lot like single replacement, but instead of having a single element replacing a piece of a compound, we have two compounds that are kind of switching partners here. So, for example, we have calcium chloride with silver nitrate, and they want to switch. So then our calcium will be paired with the nitrate, and our silver will be paired with the chlorine. So they just kind of swap partners. In the next example, we have sodium bonded with sulfate and barium bonded with chlorine. And then through double replacement, they switch partners, and the sodium is now bonded with chlorine, and the barium is bonded with the sulfate. So one thing that we can look at here is to identify this as a type of reaction is that we have two compounds that are reacting together. Whereas in the single replacement one, we had an element in a compound. And in the combination or synthesis, we had just two small pieces. And in the decomposition, we had one big thing, or we had a very complex thing that was being broken up. So a good way to identify this double replacement is that we have two compounds there. So all right, in this last example, we have lead and lithium that are going to switch partners and produce lead oxide and lithium nitrate. Okay. So our next example is combustion. This is kind of the fun one. This is fire. This is explosions. This is, what we really think of or what we want to do in lab all the time. And this is when something combines with oxygen and they need to release a bunch of energy. So our base formula here is A with H and O2. It's very important to remember that we have to have oxygen present for combustion to happen, which makes sense because you can stop a fire by suffocating it, maybe laying a big heavy blanket on it or putting a fire extinguisher and covering the flames, that sort of thing. So we are going to mix CH4 with O2, and we produce carbon dioxide, water, and energy. If we take C3H8 and mix it with O2, we get CO2 and H2O and energy. Do you notice any kind of patterns here? When we take a carbon-based compound and we burn it with oxygen, we're always going to make CO2 and water. That's not necessarily the case when you're setting metals on fire. So if we take Mg and we mix it with O2, this time we get MgO and energy. And so this one is definitely combustion because we're releasing energy, we're combining something with oxygen, but it could also be classified as synthesis or that combination reaction because you're taking two elements and you're mixing them together to make a more complex compound. Same thing for the iron. If we take iron and we burn it with oxygen, we can make Fe2O3 and energy. Again, it could be a synthesis reaction. It's also combustion because we have this big amount of energy that comes out of it. All right, the very last one we're going to talk about is neutralization. This is when we mix an acid and a base, and we form a salt and water. So neutralization is very similar to a double replacement that we had up here. It's really a type of double replacement reaction, but since it is working with this acid and this base, and every single time you form a salt and water, sometimes we kind of classify it as its own. So for example, if we take hydrochloric acid, HCl, and we mix it with sodium hydroxide, we can make NaCl and water. This NaCl is your normal table salt. If we take H2SO4 and lithium hydroxide, we can make lithium sulfate and water. Lithium sulfate is a type of salt too. I wouldn't suggest consuming it because it's kind of poisonous, but it is a type of salt because it is the mixture of an acid and a base. HNO2 with KOH will give us KNO2, our salt, and of course, water. So these are the 6 different types of reactions that we have, and each one of them are easily identified by their reactants. So if I just gave you reactants, you would be able to predict the products based off of what type of reaction it is.